All right, welcome back. In the last video, we created our purse and our coin system, and that coin system knows how to count up the value, retain the value as copper, and be able to tell you how much gold and half crowns and silver and brass and copper you have in your purse at any given time. And that works. We'll run it again. 55 copper is 1 silver and 1 brass, and that's exactly correct based on our rules, which we posted over here or put here in this. 1 brass is 5 coppers, 1 silver is 50 copper, half crown is 500 coppers, and a gold crown is 2,500 copper. So that's working. What do we have to do next? Well, we have to modify our player for one thing. This is fairly simple. Our player needs a purse. It's already got an inventory, so what we have to do is include our purse up here. Oh no, it's money.h. There we go. And what we want here is a purse underscore purse. Good. Now we want to be able to print out our purse. Now we want to do it when we print out a player. Do we want to print out how much money they've got in their purse? Right now we're printing out the player name, we're printing out their strength, health, and damage, and then their inventory. Maybe we should put the money at the top, huh? Right after the player. I need another line here, and then I want to go purse, and then we'll print out and then we'll just do this. Go grab these printouts that we did. Oh, we'll throw the value in there too. Well, we'll think about that. Let's go over here to the player. Well, actually, we could move this over to, you know what? Let's do this. Let's get rid of that. That back the way it was. Let's go over here to money. What we want to do is do this way. We need to, for this, I only need to include the OStream header. So we'll come down here and we know that it's standard OStream ampersand. That's what we're going to return. Operator. Constant OStream ampersand. No, it's OStream ampersand OS comma constant purse ampersand purse. And it's got to be a friend class, or a friend function rather. It's got to be standard. Okay. Now we can put this in here and change all of this to OS. I'll show you a trick here with Visual Studio. Visual Studio, if you press the Shift and the Alt key on the right hand side of the keyboard, I'm not sure if the other ones work, they may, and then you push their down arrow key, you highlight a single column, and then if you move over by holding the shift key only and move to the right, you highlight all that, and if we paste that OS in there, it changes all of them at once in one whack. And then we can hit escape and get rid of that column. So what we can do here is go OS from purse from standard indel, and then we'll do our little line thing as well, and I'll grab that from over here so they're all the same length. We'll put that here. And we'll put another one down here. And we can clean that up, make it look a little bit nicer. Then we want to, of course, return our OS so that they can chain together. Now all we need to do is come over here. Purse.values. Oh, we need that. Over here, what we need to do is go values equals count purse. That gets our values. Okay. Now over here in player, all we have to do is go OS from purse. It's underscore purse, right? Doesn't like something. What doesn't it like? Illegal call non-static member function. Oh, it's purse.count purse. What doesn't it like now? Cannot convert this pointer. Cannot convert this pointer from constant purse to purse ampersand. Count purse. Okay, I'll explain that in a moment. No, it still doesn't like something. Count coins, I think, also needs to be a constant. No. Get value. Purse. Get value. Also needs to be a constant. I will explain all these constants in a moment. Did I miss one? This has got to be, this is player purse. Earlier reference to non-static member function player. That's got to be player dot purse. Okay. It's a little late. Okay, it compiles. All right, let me explain these constants. All right. Constant at the after a function like get value tells the compiler that get value does not modify the state of this class in any way. It doesn't change anything in the class. All right? Why is that important? It's important because of this constant purse here. I'm calling a function purse.countPurse on a constant. If countPurse were to modify purse, it would be a violation of this constant here. So any functions that you call on a constant object like this have to themselves be constant functions here, informing the compiler that this doesn't modify any of the state of this. Add cannot be constant, and we can't call it in this context here because add does change the state of this object. But all these others, this just does calculations and returns a value. That doesn't change any state. This coin does the same thing. It calculates and returns a value. It does not change any state. So to be able to legitimately call these functions from within this friend on this constant purse ampersand purse, the functions I call in here must be constant. They must be constant functions that guarantee that they don't change any values. In fact, with this here, if I were to do something like change something in this state, I would get an error. So with this here, I'm not allowed to change any state in the class. So let's check out our player now with some money in his pocket. So let's go back to here. We don't need this anymore. Let's clean some of this stuff up. We don't need any of this anymore. We've all done it inside the player. This is our original game loop. We're not going to use that just now. Let's uncomment this stuff and see what we want to use. Let's go here and go me. Oh, we got to be able to give ourselves money. We've got the ability to count our purse. That's our purse. We need our player. We've got add item, remove item. We need to add money and remove money. So we're going to do a void and go add money. And what do we need to do? We got to say what the coinage is. Well, yeah. We'll have a simple function right now that takes coinage, coin, and int number. And all this is going to do is call underscore purse dot add coin, comma, number. And then we can have remove money. Did we do a remove from purse? Let's go to money. We've got add. We need remove. So we can do exactly the same thing as this. Well, actually, if we have a negative number, it'll add a negative number. We should do a remove instead of getting weird. We'll call this remove. If you were to put a negative number in here for number calling add, it would actually remove money from the purse. However, that would be counterintuitive using an add function to remove money. So at some point in time, we might make sure that this is a positive number. And we could actually do that by making this an unsigned integer. And it would always be positive. So let's have remove int, and we'll just change this to minus equals. And if we made this an unsigned int in both cases, it would guarantee that we can't send a negative number into there, and and do something weird, having add actually removing money from your purse. So let's go over here to our player. We've got add money, purse.add, and we need remove money. And it'll be purse.remove. So it's called remove on the purse because it's in the context of the purse already, and it's just remove. Here it's in the context of our player. We've got to say what we're removing because we have remove item, we have add item, we've got add money, remove money, and so forth. All right. Let's go back to here, and here's my player, and we'll say me dot add money coinage, C-O-I-N-A-G, coinage, colon, copper, and we'll just give ourselves 1542 copper, 1543 copper. And when we print out me, we should get our purse as well. Let's take a look. Room strength value 1543. That's what we put in, right? It is. So we have in our purse 3 coppers, 8 brass, and 3 half crowns that we can spend. And actually, we can now update our random number generator to randomly generate money. So let me see how much time we got here. 17 minutes. We're fine. For things like chests or something you might find, or a monster that drops money, we want to be able to randomly generate some money. And so let's go to random.h, and let's think about what we would do to randomly generate some money. It might be a dice throw that produces some money, but wouldn't it be nice if we had a function associated with money that used this random generator to get a random amount of money? And so we probably don't want it on the purse. What we want to do is include so let's think about this. I could go into the random number generator and make it knowledgeable of coinage and have the random number generator produce random coins, but coinage isn't the business of a random number generator. It's got no real business knowing about coinage. Our money system knows about coinage and can also know about random number generators, because random number generators are at a higher level of abstraction. So let's include our random.h, and let's make another very simple class here called random coins, and we'll say public random. Let's go look at our random again. This random number generator is private in here, and that's okay. We don't need to access that. We can access either Next or Dice or whatever from within here. So we don't need any access to that, and that's why that's private. So in money here, this class will not have any access directly to the random number generator. So we'll have random coins, and there's nothing to do to initialize it. There might be. We might create another instructor, but we do need to initialize random. So there's our constructor. And so let's go coins. Random coins int max value. We'll go int min value, and this will be in copper. So we'll say minimum min, we'll be explicit here. We'll say copper value, max copper value. Okay. So if we're going to generate random coins, look at our random number generator here. We've got this next with min max. So we can generate a random number between these two. So if we go back to money, first thing we can do is go int value equals next min equals this dot this pointer coins, random coins. Oh, I renamed this the same. Okay. We'll call it get random coins. And that's, of course, messing up IntelliSense. So we can go next. Here's next. Min copper value, max copper value. So this statement gets our the value we want this coins to be. So now what we can do is we can create a purse. So we can, and actually, I'm going to delete that. I'm going to move it all the way down here to the bottom so that we can access purse, and we can say purse temp purse. We can say purse dot temp purse dot add value, and then we can return coinage colon copper comma value, and we can return temp purse dot count purse. So let's check out our random coins one over here. We've got all this. I'm gonna do this. I'm gonna that out, and so we'll just say coins rand coins equals first we're going to say random coins are coins, we'll call it, and then we'll say coins C equals our coins dot get random coins. Well, need that. Let's put this down below that, and we want to be able to get random coins between a value of 100 copper and 1500 copper. One more thing that I think we should do is we could take this and add move this up to that. Let's take that out of there for the moment. Wait a minute. We'll copy it for the moment. So we've got that structure there. In this struct, let's put this in here. And instead of purse, this will be coins. Coins. We'll call it coins. Let's go change. We don't need this anymore. We can get rid of this part, and we can get rid of the value part and this. And what we want to do is get the, we don't want values, we just want this to be coins dot copper, coins dot brass, coins dot silver, coins dot half crown. Okay. Down here, we'll still print out that and the value, but instead of printing all this stuff, we'll go OS from values. Now, back here in this, we can just say standard C out from C. Hopefully. What's wrong with that? Right there. I don't know how that semicolon got knocked off of that. Oh, there it is, 1741. So we're randomly generating money now. If we run it again, they'll be different. 4641. Also, we cleaned this up a little bit. This is responsible for printing out its data. This is responsible for printing out its data and what's in the values and so forth. We keep staging that up. It makes things simpler. This is really about a combination of things. This is about encapsulation and single responsibility principle. This thing's got responsibility for this money. This thing's also responsible for printing out the money. This thing's responsible for the overall purse and printing out the actual values inside and so forth. So let's see how much time we got. Yeah, we're at 28 minutes. So, okay. We've got our random purse now, and we've got a purse applied to the player. We've gotten the ability to generate random money. So, you know, when a player first starts up, we could very simply come in here and, well, I mean, for their actual purse, we could generate it right from the random number generator. That was more for you know, creating chests and stuff that have a certain numbers of actual coins in there that you can collect, and we'll see that. You know, when you look in a chest, you're going to see a random set of coins. So we could have done that a variety of different ways, but I kind of like the idea of creating a little bit of inheritance there and creating our random coin generator. So different things you can do and different approaches you can take. It's not necessarily wrong to do it one way or another. But anyway, that's it. Thanks for watching. I hope you enjoyed the video. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And if you want to get notifications when I upload videos, hit that notify button. Thanks, and I'll see you in the next video.